This is lesson 1-2, sets of real numbers, and we're going to learn how to classify numbers. The way that I like to explain these is um, how you grew up. So let's start after you're born, you're a baby, and you're learning numbers for the first time. You start counting with the number 1, and then 2, and then 3. You start there naturally. So, and your parents, it's easy for them. They one pencil or one cookie. So it was easy for them to teach you about the numbers 1, 2. But the natural numbers are 1, 2, 3, 4, 5, 6, and on. You keep going. Um, then, as you get a little older, you were able to understand zero and that zero represents nothing. If you're a baby and you say, oh, you have no toys, a baby doesn't really understand that. But as you get a little older and your brain develops, you understand that zero is included in numbers. So the whole numbers takes all of the natural numbers and then adds on zero. So we have 0, 1, 2, 3, 4, and you can continue counting. Then again, as you get a little older and you are in elementary, higher elementary, or early middle school, you're learning about integers. Integers are when you take all those numbers that you know about and you include their opposites. So all of those whole numbers that you already know, you include their opposites. And the opposite of 1 is -1. The opposite of 2 is -2. So all of the negative whole numbers, all the negative values, and the positive values and 0 are in the set called integers. Now, as we continue moving on, you learn about rational numbers. Now, rational numbers brings in your fractions and your decimals. Um, a rational number is any number that can be written as a fraction, as a over b, or as a ratio, a over b, where the a and the b are in the set of integers. So the set of integers includes all of these numbers that we've already talked about, the natural, the whole, and then their opposites. So if it's in the set of integers and you can write it as a fraction, then it's a rational number. Um, remember that b cannot be 0 because it would be undefined. Also, rational numbers. When you have them in decimal form, the decimals may repeat or they may terminate. And terminate means they stop, like 0.5, the end. So if it repeats or it terminates, it's a rational number. Now, irrational numbers, in a decimal form, these numbers will not repeat and they will not terminate, like the value pi. We'll also talk about a value called e this year. Um, if you know anything about pi, a lot of people say, oh, it's 3.14. Well, it's not 3.14. That's its approximate. That's its estimate, but it's 3.1415, and you keep going on and on and on, and it never repeats and it never ends. Um, Also, in the set of irrational numbers are square roots of numbers that are not perfect squares. So, looking here at this example, the square root of 3. 3 is not a perfect square. If I tried to get the square root, I'm not going to get a nice whole number for my answer. But if I had the square root of 25, I would. So the square root of 25 would not belong in the irrational set. Now, all of these that we have talked about are considered real numbers. So you want to, anytime you classify them, you want to start in the earliest set that you would find the number in, and then also you need to make sure that you tell all of the sets that it's included in and real numbers because they're all part of the real number set. So let's look at these examples. So we have the square root of 25. And since you can simplify this to 5, we would say, well, where does 5 start? Where's the earliest set? Well, when you were a child, naturally you would learn 5 as part of the natural numbers. And then as we move up, it would be included in all of them. So the natural, the whole, it would also be included in integers. We can write it as a rational number, 5/1. It is not irrational. And then real numbers. It is real numbers because it was included in all of these sets here, which is part of the real number set. So I would be able to write natural, whole, integer, rational, and real. Now if you look at the square root of 7, 7, I don't have, this one had a perfect square. The 25 had a perfect square here. But 7, there's not a perfect square. So this would be an irrational number. So it's irrational. It's also considered real. Go back up here and we notice irrational are also under the heading of real numbers. And then -4. This number is not natural or whole because the negative part, the negative did not appear until you got a little older. And so the negative only appears in set Z. So you could only classify this as integer, rational, and real. So you try some. Thank you.